My name is Joe Collette. I'm a faculty member at Minot State in the geology department, and I am an associate professor. LIDAR just stands for light detection and ranging, and essentially it's the same thing as a laser rangefinder, but instead of one spot, you have 16 individual emitters that are rotating on a drum that's spinning at about 6,000 RPMs. You can paint a very accurate three-dimensional landscape photograph if you want to think about it that way, and then use that sort of photograph or snapshot to be able to solve different kinds of problems. What we've been working on more recently is trying to figure out where people are buried. Eventually, all of the soft tissues that make up the vast majority of our volume eventually goes away through desiccation and through microbial degradation. All of the soil that sits on top of the body sinks down into the interstices that are left behind, the voids that are left behind, and that creates a very shallow swale at the surface. And we're only talking about, maybe a centimeter or two at the surface anyways, which isn't something that you can see with your eye very well. But LIDAR picks it out just like it's a sore thumb. We're generating 6,000 data points every second. Being able to take those data points and do things with them requires being able to take that data and manipulate it and generate other deliverables from the initial raw data. And there are lots of different kinds of data types that fall under the category of remote sensing. So you can do photography, you can do infrared, ultraviolet, multispectral imaging, where you take each color band individually and then you can combine them together in a bunch of different ways to solve problems related to agronomy and vegetation cover and things like that. You can do weed detection, which is called visual phenotyping, which is a pretty cool new technology that's sort of taking off. If you fly over a wheat field, for example, with a drone, and you're looking for scotia, you can look at the specific frequencies of light that are being reflected off of those, and there's a distinct color difference between wheat and between noxious weeds. And so if you find that your noxious weeds are only in the southwest corner of your field and the rest of your field is 99% fine, why pay a pilot to do that when you can identify that, go out there and spray that, and you're done? Coming in and talking to us about what you can do with remote sensing, what you can do with geosciences, how you can relate that to biological problems, geological problems, historical problems. These are all kinds of things that we want to talk about. These are things that we're interested in getting students in the door to work on. So the career paths that you can go after with a remote sensing degree are going to be increasing dramatically over the next few years. Remote sensing is going to be used for everything from pipeline monitoring to setback monitoring in terms of the distance that trees can be from transmission lines. All of the measurements for new and existing oil pads, all of that kind of thing is going to be measured from drone footage, from photogrammetry. You can answer any question with it. This stuff is just going to continue to be a part of the economy in North Dakota. We do two things in North Dakota better than pretty much anybody else. We do energy and we do agriculture. And the applications of remote sensing to both of those fields are increasing year over year.